Today we're doing problem 716 max stack. Design max stack data structure that supports stacks operation and supports finding the stack's maximum element. So pushing, popping top without remove, pick max with so get max without remove and pop max without the remove. Only remove the topmost one. That's interesting. So O1 for top and login for each other. That's interesting. So what I'm thinking is that we want to have an ordered structure, but somehow also remove elements inside of it fast. So what I'm thinking is maybe we could use a doubly linked list and then we can do top as tail, pop easily, push easily. What about peak max? Well, we could store that node somewhere. We could have like stack of maximums. And then I don't know, that will be tough. So instead, let's do a set, right? And inside of set we insert pairs with index and value. They will obviously be ordered, and we can easily pop, push, pop max easily because we can store what is maximum along with its index, right? So the last index. And no, for pop max we would need to store like we could have an actual stack of maximums, and we could we would know also what is index in real, right? So we could remove it, real stack, and top, I mean, we could keep last element. Why not? I mean, why not? Okay, first question, can we get called top, pop, peak max or pop max when it's empty? No? Okay, so that's about it from my side. There is always at least one element. Okay. So let's comment it down. We will have like a stack which is pairs of index value. Then we will have like indices, hash map with key equal to value and value equal to list of indices in stack. Then we could have top, which would be variable with top of stack, and then we could have like max stack pairs of index value. Well, we could like stack index, right? And now push update top if larger, if max so far, update max stack, no, push to max stack, add to indices and add to stack. I don't know, or I should have put a normal stack, push to stack and max stack. Okay, then we got like pop, which means update top. If it was max, pick remaining previous index, or do I actually need to do that? Because I mean it's stored in there, so technically I don't need indices. Right, so update top, pop from max stack, if last of step is last of max step, indices match, no, yeah, indices match, matches, pop from step, I guess, then we get top return variable, tick max, return last of max stack, pop max, remove from stir, update top if it was last, remove from max stack. I guess that's it. So let's initialize our variables. And then we can have like stack and max stack top, right? And then what could be the values? I mean, we'll have it initialized, right? So we don't do anything here. Here this top is x, right? Then if x, if stir empty, then stir push back 0 x max, the max we push 0x, right? And insert, right? If it's not empty, then we wanna do like so we can do like int index is this the size. Okay, then so start insert index x, and now I mean technically we could keep max, right? Just to make our lives easier. this max is equal to x, right? And now if x max, then max is x, this max the push index x, right? Meaning that we just keep all, we will do peak max easily, but that doesn't matter now. So for pop, we do, that's right. I mean, we don't technically have to update pop if it's empty, so we could do like index is size minus 1. So int index this the size minus 1 if index is equal to this max the, and then we take whatever, right? And then we take what? Erase? Nah. Index is equal to begin. So technically we do this, I guess, and then from this we need to know the index, right? So first they are saying that this max the erase, this max the begin, whatever, this the erase. Nah, we need to do maximum, whatever. And this erase, this begin, fair enough. And now so this is okay, and now if not this max the empty, then this max is foof. If not this the empty, and return what value did I even erase? That's crazy. Okay, so top is return this top, return this max, and then pop max. That's almost the same, but you just reverse the stuff. So index is equal to max the begin first, right? So that's real index. This might work, but I'm not sure, so let's see. So if index is equal to st size minus 1, then st erase index value, then result is is all these values, so we don't care. Okay, so then we erase it from max, still erase max the rbegin, and now if it's not empty we update that stuff. Okay, that should work. What the hell? Okay, let's call it like that's rbegin. Okay, that's I mean that's way easier. Oh my days, I'm done. This right, this rbegin. Yeah, because it needs to be and minus minus, I think, or minus minus and like this, and then yeah, this needs to be pop and unpointer. Okay, that works, and then max stack pop, and then max stack and then stop second. Works. Okay, so you push 5, push 1, pop max, peak max. Yeah, I didn't think of that stuff. Yeah, I didn't think about what happened when I nailed the first element. Oof. Oh no, we'll just have max stack will be ordered by value pair, right? So this will be like value index. So we do this, and then into max stack we insert this, right? And then max stack rbegin erase like that, and then this is rbegin second. Okay, now we are here, so that's rbegin like that, blah blah erase. Okay. push, push, push. So first you get top, which should give you 5. Then you do pop max, which should also give you 5. So index is the second value, and value is first value, and then this is result index, and this should be first in here. Okay, kind of works. Okay, breaks immediately, push, 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 peak max. Could work. Great. Push 74, pop max. Push 89, push 67, pop max. So you should have 89, pop 67. Push 61, push minus 77. Something is wrong with this. Push pop, push push pop pop, push push pop max. So this is last. What? No. Okay, now this is correct, and suddenly there is 67 here. Where is minus 77? So we take index of this. If that index is equal to max stack index. No, you always erase from there. Okay. Even less? That's crazy. Push pop max, so you remove 1, then you have minus 95, minus 44, 16, you get 16, then you get 29, 65, minus 18, so you get 65, 29, minus 18, minus 44, minus 95, and then you get pop. push, peak, push, 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 peak, pop. So you get 90, 23, you remove 90, and then you add minus 40. And then you pop, pop, and for some reason you got first pop, push, peak, push, 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 peak, pop, push, 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 pop, max, pop, pop here. Oh, okay, I got the resetting. So fun. Oh, I should be in here. Nice. Oh, what? I didn't want to submit. Set end 0, 1, 0, 1, whatever. So that's push 72, peak max, push, 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 peak max. No, push, 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 so push, 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 push. Declaration, then we got one push, in peaks max there is nothing, so we got second push, first push, fourth push. Then the fifth push is during peak max, so there should be two, right? So okay, that's fair. Then in push minus 50, 90 and 23, 90, and then you do pop max, push minus 40, and so something is wrong. Yeah, the indices are bad, completely bad, bro. So something wrong with indices, but that's okay, we'll update it every time. Okay, now this is wrong. This is actually quite fine. Only pop max won't work. 74 pop. So that's pop pop, right? That's init push before pop, after pop, push push, pop pop. So we do, this is first pop, this is second pop, then we got push push peak pop, push push peak pop. And where is the mistake? Push push peak pop, push push peak max pop max. Why is it not the same? Forgetting to update max, am I not? Yes. I think that's the problem. There needs to be like an else. Why is there a break? Ugh. Of course. Oh, but just 10 cases. This works, so there is just some bug. Okay, let's try to submit this. That will probably pass, but I can speed up the max calls. Back to boring struggle with hard problems, am I right? So Such a pain. And that's not a hard problem. Top, whatever. Minimize is the remove. Okay, balanced. That's okay. Wow, that's so simple. Since when is this all one? Oh my god, bro. Why am I even bothering with that pointer stuff? Ridiculous, mate. Ridiculous. Like I could really shorten it to max the begin first, the begin second, and then I could straight up just do this, and that's it. Like I don't have to do anything, and I just absolute scam, like absolute scam. Of course I can do it this easily. Absolute robbery, rubbish. Map, vector, list, int, iterator, and list. V insert. What? Question is, why don't you do an ordered map? So first we insert at the start of the list, and then we insert pointer to the node, right? Pop if we take first, we remove it, and then we erase begin, npr begin first. Okay, so you can do it with linked list. My question is, why couldn't you do this with an ordered map? Or because you want the maximums to be ordered? Okay, so you could do it with linked list, but that's, how does it do this though? I guess. I should read up more on this, but I really don't have any time at all, absolutely. Heaped on stack to remove. Heap key push, negate to get max, push to stack, count, pop. While removed at index. Okay. Ooh, that's all unamortized, bro. What the hell? Peak max. Oh, that's crazy. Oh, for sure I'm doing linked list, bro. For sure I'm doing linked lists. Ain't no way I'm doing linked list, bro. There is no way. O1 log and pop, log and push. I guess. SMH. Whatever. Let's just write it and use one balance tree as the stack using pairs of ID X and where ID is increasing or is emit is a global variable where test case. Okay, and for maximums we have balance x3 with pairs xid to get off of stack. We simply remove pushes you could just use keep slash balance tree for the max speed, and each time you remove something end of stack or max element, mark the ID of the removed value into removed hash set, and for each operation, for each read or slash erase operation, first pop the removed elements. First skip the removed elements. This makes all methods, but I mean, push would be login, right? Copies you take last in market, so that's 01, I think. View stack, these are 01, and pop max I'm not sure actually. So just read this 01. Pop is 01 also. Okay. This makes the top and pop functions 01 amortized. Others remain. I guess. Okay, I just SMH. See you tomorrow.